Summary reports on scientific research and training results. Good morning, professors. It's my honor to be with you today. My name is Nguyễn Thị Tố Loan, a chemistry teacher at Thái Nguyên University of Education. Today, in front of the culture, I am happy to present the summary of my scientific research and training results during 10 years of teaching. My report consists of 5 main parts. The first part is my education and employment background. The second part presents my scientific research achievements. The next part consists of my undergraduate and graduate training results. The fourth part lists some typical scientific papers and projects. And in the final part, I give out the next research orientations. Firstly, I would like to introduce my education and employment background. After graduating from Thái Nguyên University of Education in 2003 with a good certificate, I became a graduate student at this university. In 2004, I have worked as a lecturer at Chemistry Department, Thái Nguyên University of Education. In 2006, I successfully defended my master thesis. This year, I continue enrolling at Chemistry Institute, Vietnam Academy of Science and Technology as a PhD student. I successfully defended my PhD dissertation at Chemistry Institute, Vietnam Academy of Science and Technology in 2011. During my 10 years of teaching, I have been directly involved in teaching students for 9 chemistry full-time courses and in service classes at the Department of Chemistry, Thái Nguyên University of Education. Teaching and scientific research are two important tasks of those who work at the university. The two tasks support each other and mutually develop. Thanks to help from the experienced and previous researchers, during my 10 years of teaching at Thái Nguyên University of Education, I have always striven to become a highly qualified and professional teacher to meet the requirements of training objectives of the university and have enough necessary capacity to fulfill the tasks assigned. Secondly, I would like to present my scientific research achievements. In terms of scientific research achievements, I follow the main orientation, that is, synthesis of nano-oxide materials, mixed oxide, and studies on their structure, properties, and application orientation in environmental treatment. The main results obtained from this research direction were published in journals including 29 scientific research projects, particularly first, having researched and applied gel combustion method using polyvinyl alcohol, PVA, and other agents for the synthesis of metal oxide and compound oxide nanomaterials for high efficiency. Second, having studied the structure, composition, and some physical chemical properties of the synthesized materials using modern methods such as X-ray diffraction methods, methods of scanning electron microscopy, transmission electron microscopy, energy dispersive X-ray spectroscopy, solid phase ultraviolet visible spectroscopy. Third, having researched synthesis of single nanosite oxides, ferric oxide, manganese dioxide, zinc oxide, nickel oxide, and zinc oxide with manganese 2 ion, iron 3 ion, aluminum 3 ion. In order to handle some heavy metals, ions, and organic pigments in water, we have examined the effect of several factors on the process of creating phase and the particle size of oxide such as heating temperature, heating temp, gelling pH, the proportion of metallic mole PVA. For example, the optimal condition to synthesize nanosine gamma ferric oxide are heating temperature 250 degrees Celsius, heating time 3 hours, proportion of iron 3 iron PVA is 1/3, proportion of iron 3 iron ammonium nitrate is 1/4, gelling temperature 80 degrees Celsius. The synthetic nano-oxide is single-phase image 1. Its particle size is 10 nanometers image 2. Its specific surface area methods by batch methods is 39.5 square meter gram. We also study the absorbent capacity of nano-oxide gamma ferric oxide on iron 3 iron, manganese 2 iron, Sn 3 and Sn 5. The result is that the maximum absorbent capacity on iron 3 iron is 150.7 milligram gram. On manganese 2 iron is 138.89 milligram gram. On Sn 3 is 48.2 milligram gram. And on Sn 5 is 57.9 milligram gram. With nanoscale, metallic oxides appear to be the optimal absorbents for heavy metals. However, it is difficult to use them in reality because they nearly cannot be separated from the liquid after the absorption. Therefore, we decided to use quartz Sn as the carrier in order to disintegrate the nano-oxide of manganese and iron in our next research. First, we synthesize and study the Sn iron manganese absorbent capacity of materials containing gamma ferric oxide and beta manganese dioxide covering quartz sand. The experimental results of materials containing gamma ferric oxide was the maximum absorbent capacity on iron 3 iron is 4 milligram gram. On manganese 2 iron is 2.93 milligram gram. On Sn 3 is 1.71 milligram gram, and on Sn 5 is 1.89 milligram gram. The experimental result of materials containing beta manganese dioxide was the maximum absorbent capacity on iron 3 iron is 3.14 milligram gram. On manganese 2 iron is 1.79 milligram gram. On Sn 3 is 1.45 milligram gram, and on Sn 5 is 1.66 milligram gram. The materials containing gamma ferric oxide and beta manganese dioxide covering quartz sand are applied into the household equipment that absorb arsenic, iron, and manganese in water. Image 6 and 7. Fifth, having researched synthesis of some complex nano-oxide spinels by combustion methods in order to serve as photocatalytic materials in the decomposition reaction of toxic organic compounds in water. zinc iron spinel was synthesized under the following condition. Heating temperature was 500 degrees Celsius, mole proportion of zinc 2 iron 3 iron PVA was 1/3. Heating time was 3 hours. Gelling temperatures were 80 degrees Celsius. Heating time was 3 hours. After 2 hours of heating gel at 6 degrees Celsius, we got zinc aluminate spinel. All of gained spinel oxides were global with a size under 20 nanometer and a large specific surface area over 39 square meter gram. Finally, we study the catalytic capacity of zinc aluminate spinel, zinc iron spinel in decomposing red phenols. The result shows that all of these chemicals can be used as photocatalysts in decomposing red phenols reaction. Also, we carried out a research on the effects of other factors such as time, temperature, concentration, weight of catalysts in decomposing phenols reaction. In the first part, I would like to present my undergraduate and graduate training results. In terms of undergraduate training, to effectively apply methods of active teaching, I have compiled and published one textbook for undergraduate training, namely Inorganic Chemistry 2 textbook, Coordinator, which was collected by the University Council of Training and printed to cater training activities. This is a very practical document for students of chemistry. In terms of graduate training, after my doctoral defense in 2012, I commend supervision for MA thesis. I have read, commented, and evaluated many master theses, supervised 5 graduate students to successfully defend their MA thesis that study on several nano-oxide materials, composite oxide, and their structural properties and oriented applications, environmental treatment. The next part is the list of my 5 major projects and papers that I am most satisfied with. First, Nguyễn Thị Tố Loan 2014, Syllabus of Inorganic Chemistry 2, Education Publishing House. Second, Lưu Minh Đại and Nguyễn Thị Tố Loan 2010, Research Synthesis of Nanomaterials, Gamma Ferric Oxide for Absorption of Arsenic, Iron, and Manganese, Journal of Chemistry, Volume 48, for a page 180 to 184. Third, Lưu Minh Đại, Nguyễn Thị Tố Loan, and Võ Quang Mai 2011, Producing Quartz Sand covered with nano-oxide, beta-manganese dioxide, and gamma ferric oxide to absorb arsenic, Journal of Chemistry, Volume 49, 3A, page 6 to 10. Fourth, Nguyễn Thị Tố Loan and Nguyễn Thị Vân Anh 2013, Research Synthesis of Zinc oxide nano-oxides doped with cerium using gel combustion method, Journals of Chemistry, Volume 51, 6ABC, page 734 to 738. Last but not least, Nguyễn Thị Tố Loan 2013, Research Synthesis of Nanoside Zinc Iron Spinel using Gel Combustion Methods, Journals of Chemistry, Volume 51, 3AB, page 123 to 125. In the coming time, I continue to focus on the following research orientation. First, To continue research synthesis of inorganic nanomaterials, looking for new properties and exploring the possibilities of application in other fields such as energy and biomedicine. Second, to use different methods of synthesis based on synthesis conditions and seeking new synthetic agents to synthesize the materials with new structures and components containing better properties for environmental treatment. Third, to continue studying innovative teaching methods for undergraduate and graduate education in accordance with the credit training system in order to improve the quality of training. In conclusion, being a lecturer at university, I have constantly striven to foster myself, and I am clearly aware of my responsibilities in training future teachers. I will continue doing research in order to improve my professional skills and to meet the requirements of science and technology in the integration of our country. That's the end of my presentation. Thanks for the attention of the council. Wish all professors be healthy and happy.